Okay, now we're going to take a quick look at AP Physics vertical motion. On to problem number 5, which is a really straightforward and quick and simple one. So problem 5 here says, hey, a ball is thrown upward at 29.4 meters per second. Can you find its velocity at 1 second, 2 second, 3 second, 4 second? Careful, 6. I skipped 5. I don't know why I skipped 5. I'm just trying to cut some work out for you. Anyway, here we go. So take a look at that. Problem 5. Okay, so I'm going to throw this ball upward, right? And it's going to start off here at 29.4 meters per second. You say 29.4, that's a oddly specific value, Mr. C. And you say, yeah, here, look, the V at 0 is 29.4 meters per second. Perhaps you recognize that that is a multiple of 9.8. You're welcome. And so they ask, hey, how fast will it be going 1 second later? You say, well, it has this acceleration negative 9.8 meters per second squared. You say, hey, what is that acceleration of negative 9.8 meters per second squared? Well, again, you know what that means. That means that we are going to subtract 9.8 meters per second every second. So 1 second later, how fast will it be going? You say, well, I'm going to subtract 9.8 from it. So a second later, it will be traveling. Subtract 9.8 from 29.4, and you're like, 19.6. And so a second later, now the velocity is, don't ask why the ball got smaller. Now it's only going 19.6 meters per second. Okay, and that's my velocity at 1. And then you say, hey, what about a second after that? You say, well, again, another second later, at 2 seconds, I'm going to subtract another 9.8. 19.6 minus 9.8 is going to be, again, it's getting smaller. I don't know why the ball keeps shrinking. It's going to be going now, the velocity at 2 seconds is 9.8 meters per second. And you say, okay, what about at 3 seconds? Well, if I subtract 9.8 from 9.8, that means the velocity is going to be, that's right, the velocity at 3 seconds is in fact 0 meters per second. And we are where? We are at the peak, okay? The velocity is always 0 when you're changing directions. And then you say at 4 seconds, well, I'm going to subtract 9.8 again. And so 0 minus 9.8, I'm going to be going at negative 9.8. And we know that we'll be back at that height, because that special relationship here for situations like this. So the V at 4 is going to be negative 9.8 meters per second. And you say, and then at 5, I would be here, and at 6, I'd be down here. And by the time I get to 6, you say, again, this is going to be, wonk, 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 right? Equal and opposite, right? And these are equal and opposite, drunk, drunk, and these are, what did I just say? These are equal and opposite. Whoops. This one that they didn't ask us about, the V at 5, the V at 6 is going to be a negative 29.4 meters per second. This is going to be dunk, dunk, and dunk, dunk, dunk. Right, there we go. Okay, good enough. And that is problem 5A. Problem 5B asks, can you find the ball's acceleration at all these times? And you say, what, are you kidding me? I know that the acceleration is constant. I know that the acceleration is going to be negative 9.8 meters per second squared for all those times. And that is problem number 5. Hope it wasn't too onerous for you.